Have you ever wondered about that eerie red glow you always see in movies? In submarine control rooms or airplane cockpits? Well, that's not just for dramatic effect. It's actually a really brilliant scientific hack that protects one of our most amazing abilities, our night vision. So let's dive in and figure out the science behind that glow. So what's the common thread here? From the deep ocean to 30,000 feet in the air and even your local movie theater, they all use this one specific color to light up the darkness. So why red? What could sailors, pilots, and us moviegoers possibly have in common? Well, the answer is actually hidden inside our own eyes. To solve this little mystery, we have to look at how our eyes work. And it turns out, your eye isn't just one camera. It's more like this super advanced gadget with two completely different camera systems built right in. One's for the day, and the other is purely for the night.
All right, so let's meet the two stars of the show, rod cells and cone cells. Your cones, you can think of them as your daytime crew. They're your high-definition, full-color camera, and they're fantastic for seeing sharp details and bright colors when it's sunny out. But your rods, well, they're the night shift. They are your super-sensitive, black and white night vision specialists. They're the whole reason you can find your way through a dark room without bumping into everything.
And when I say they're super sensitive, I am not kidding. Your rod cells are about 100 times more sensitive to light than your cone cells. I mean, they can literally detect a single photon of light, the smallest possible unit of light there is. It's a genuine biological superpower that we all have.
Now, of course, science has a fancy name for this superpower, scotic vision. It's just a technical way of saying night vision, and it relies completely on those incredible rod cells. This is the amazing ability that we're trying to protect. But how does it work on a chemical level? And maybe more importantly, how do you break it?
Well, the secret lies in a special chemical that acts just like a rechargeable battery for your night vision. It's a molecule called rhodopsin.
So rhodopsin is this light-sensitive pigment that's packed inside of your rod cells. The moment a single photon of light hits a rhodopsin molecule, bam, it triggers a chemical reaction that sends a signal straight to your brain. This one little molecule, it's the absolute linchpin for your ability to see in the dark.
And this all works in a fascinating cycle. When you're in the dark, your eyes are working hard, building up a big supply of this rhodopsin. But the second you're hit with bright light, poof, that whole supply gets bleached. It's used up almost instantly. And here's the real kicker. It takes a long time, anywhere from 20 to 40 minutes in total darkness, for those rhodopsin batteries to fully recharge again.
So you can see the huge problem this creates for, say, a sailor on night watch or a pilot in their cockpit. How are you supposed to read your instruments or check a map without flipping on a bright light that would instantly nuke your precious night vision, forcing you to wait another half an hour to adapt all over again? There's got to be a trick, right? And this is the trick. This is the big aha moment. This chart shows us what our rod cells, our night vision cells, are actually sensitive to. You can see they go absolutely nuts for blue and green light. That's their peak sensitivity. But look what happens when you go all the way to the right side of the chart, to the long wavelengths of red light. Their sensitivity just plummets. It falls right off a cliff. Our rods are basically blind to it. And that's the whole secret. That's the hack. Your night vision system, the one powered by your rods and all that rhodopsin, it just doesn't really see deep red light. It's the perfect biological loophole. The red light is on, so your cones can see, but your night vision system doesn't even know it's there. So it doesn't get used up, it doesn't bleach the rhodopsin, and it doesn't ruin your dark adaptation. It's just genius. So this incredible little quirk of our biology is exactly what those submariners, pilots, and even cinema designers are exploiting. Let's take a look at how this all plays out in the real world.
And this isn't some newfangled discovery. People have known about this for a long time. This quote is from all the way back in 1942, from a U.S. naval publication. They'd already figured this out during World War II, and they knew it wasn't just about using any old red filter. It had to be a very specific wavelength of red light, one that was long enough to be totally invisible to the rod cells.
For sailors on night watch, this isn't just theory. It can be a matter of life and death. Imagine going from a brightly lit chart room out onto a pitch-black deck. With normal light, you'd be functionally blind for several very long, very dangerous minutes. But if that room was lit with red light, you step outside and your night vision is instantly ready to go, preserving that critical peripheral vision you need to spot a hazard, an obstacle, or anything else in the dark.
It's the same exact logic in aviation, where this is absolutely critical. Inside a red-lit cockpit, a pilot's cone cells can easily read all the vital instruments, no problem. but their rod cells stay completely untouched, fully charged and ready for night vision. This means they can glance down at their altitude gauge, then immediately look up into the dark sky and spot another aircraft without missing a beat.
And you've definitely experienced this yourself at the movies. Those red exit signs and the little lights on the floor, they are a perfect compromise. They're just bright enough for your cone cells to see them for safety's sake, but they don't create a distracting glare that pulls you out of the movie or ruins your eye's ability to see all the rich details in those dark, shadowy scenes up on the screen.
Now, this whole visual hack is brilliant, for sure, but it's not perfect. Like any tool, it has some pretty important trade-offs you need to know about.
Okay, so the biggest advantage is obvious. You preserve your night vision. But this hack comes with a really fascinating trade-off. Imagine you're that World War II pilot again, looking at a tactical map under that red cockpit light. Well, what if crucial locations on that map were marked with red ink? They would completely disappear. Why? Because the red ink just reflects the red light right along with the white paper, making it invisible to your cones. It's a perfect example of how this trick really limits your ability to see certain colors.
So when you boil it all down, the principle is just so simple and elegant. You're using red light to see with your cones while keeping your rods fully charged and saved for when you really need them. And that leaves us with one final thought. Now that you know the secret of red light, think about it. From amateur astronomy in your backyard to just navigating your house at night without waking everybody up, where else could this simple, elegant visual hack make a difference in your life?